Hey guys, you're welcome to my channel. Today we want to look at temperature and its measurement, and I would like you to pay max attention to this class. When you talk about temperature, we all know that temperature is the degree of hotness or coldness of a body or a substance. But this definition is not actually what temperature simply means, because by that definition we might not be able to state the characteristics of temperature or understand its usage. Are we together now? Therefore, if you are yet to subscribe to this channel, please don't forget to do that. Like this video and share with your friends, and if you are watching, kindly watch till end. Thank you as you do. You are the one that can assist this channel to grow. Now let's back to class. The degree of hotness or coldness that would define temperature to be is just for us to understand the meaning of temperature. Now, from that definition, I'm going to bring out some other definitions of temperature. Now, when we say the degree of hotness or coldness of a body, this is actually what we call temperature. This tells us when temperature is high and when temperature is low. So for a body whose temperature is high, it is ascribed that the body is hot. Are we there? And for a body whose temperature is low, that is what we call the coldness of that body. So you understand now that it is temperature that actually lets us know why a body is hot or why the body is cool. Now, if a body is hot, it has high temperature. When a body is cold, it has low temperature. Now, back to the property of a substance that travels from one substance to another as a result of temperature difference, which we refer to as heat. When you talk about heat, heat is the transfer of energy from one body to another as a result of temperature difference, which means that heat will always flow from a body with high temperature, since we understand that when a body is hot, the temperature of that body is high. So heat will flow from a body whose temperature is high down to a body whose temperature is what? Low. Now, what will make us know that this is the one that the temperature is high and this is the one that the temperature is low? It's as a result of the one that is very hot and the one that is very cold. That means it is temperature that will actually let us understand the direction of what? Heat flow. Are we together now? So the direction of heat flow is being defined by temperature. If that should be the case, we can now define temperature as the property of a substance which decide which way it will flow when the substance come in contact with another substance. I will take the definition again. Temperature is the property of a substance which decide which way it will flow when the body come in contact with another body. Are we together now? So do we understand that now? So if I have a body whose temperature is 20 degrees Celsius and I have a body whose temperature is 5 degrees Celsius, it's obvious that the one with 20 degrees Celsius will be hotter than the one with 5 degrees Celsius. Which simply means that if 20 degrees Celsius will come in contact with 5 degrees Celsius, heat will flow from this to this. Do you understand this now? Good. Now that we've understand the definition of temperature, there are other definitions of temperature as a result of other things that might happen when heat flow from one body to another. When heat flow from the body of 20 degrees Celsius to body of 5 degrees Celsius, what will happen is that they will later reach a state whereby the temperature on this will be the same thing as the temperature on this. By the time the temperature of this body reduced to 12.5 degrees Celsius, this one must have increased to 12.5 degrees Celsius as well. Now, at this temperature, the two bodies has the same temperature. And we said that it will only flow from one body to another when there is difference in temperature. But as at this time now, there is no difference in temperature, and when there is no difference in temperature of two bodies, we say they are in thermal equilibrium. What will make you know that a body is at thermal equilibrium? You will only know that a body is at thermal equilibrium when the net flow of heat between the two bodies is equal. Because we cannot decide that there is no heat flow between these two bodies. There is heat flow, but the rate of heat flow is equal. So it will appear that the two bodies is at what? Thermal equilibrium. Do you understand this now? When the temperature of two bodies is of the same value, we assume that there is no net what? Flow of heat. Why do we say there is no net flow of heat? Is because the rate of heat flow between the two bodies is equal. Are we together now? Therefore, we call this kind of state of equal temperature thermal equilibrium. So, what make us know that the bodies are in thermal equilibrium? We only know that the bodies are in thermal equilibrium just because they have the same temperature. It is temperature that will make you know that two bodies are in thermal equilibrium. Therefore, we can now define temperature as the property of a body that decide either or not the body is in thermal equilibrium with another body in contact. Are we together? The temperature is the property of a substance that decide either or not the body is in thermal equilibrium with another substance in contact. Are we together? Good. Now that we've understand other definition of temperature aside from the degree of hotness or coldness of a body, we can now move on to how to measure temperature. How do you measure temperature? We use thermometer to measure temperature. Are we together now? Because thermometer uses what? A substance that is physical. The substance is physical. The substance is sensitive to change in temperature. The substance is physical, that's the first condition. Secondly, the substance is sensitive. And thirdly, the substance is measurable. The substance is measurable. Are we together now? And another thing is that the substance must be reversible. The substance must be reversible. So when you say thermometer is what we use in taking temperature of a substance, then it means thermometer is making use of a substance whose is physical, is what? Sensitive, measurable, and what? Reversible. These are the characteristics of that substance. So a substance that has these characteristics is what we call thermometric substance. That is, thermometer is used in measuring temperature, and thermometer make use of a substance known as thermometric substance. And the characteristics of a thermometric substance include being physical, that is, it must be visible, sensitive to change in temperature, measurable is something that you should be able to determine its value, and what? Reversible, something that whenever it goes up, it should be able to calm down. Are we together now? So that is that about that. Now, different thermometers has different thermometric substance, because in universe we don't only have one thermometric substance, we have different thermometric substance. So we are now going to be mentioning what? Thermometer and their thermometric substance. Now, the thermometric substance behave differently to change in temperature. The way they behave to change in temperature is quite different. Therefore, there is something we call thermometric property. So for every thermometer, so when you have a thermometer, that thermometer will have a thermometric substance. And the thermometric substance will definitely have a thermometric property. Are we together? So these are the things we want to consider. We are going to consider the type of thermometer, the thermometric substance in it, and the thermometric property. Remember, the substance that is there in the thermometer is the thermometric substance. And the behavior of that substance to a change in temperature is what we call thermometric property. Are we together? Therefore, we have liquid in glass thermometer. Liquid in glass thermometer can either be what? Alcohol or mercury. So when you talk about liquid in glass thermometer, you either talk about the one that uses alcohol as a thermometric substance, or the one that uses mercury as thermometric substance. Are we together now? Good. So first one is liquid in glass thermometer. The thermometric substance there can either be alcohol or mercury. And the thermometric property is the change in volume of alcohol with a change in temperature. That is, change in volume of alcohol or mercury, depending on the one you are using. Are we together now? With a change in temperature. That is the thermometric property. Secondly, we have constant volume gas thermometer. The constant volume gas thermometer make use of gas. And the gas in it can either be hydrogen or helium. But they majorly use what? Helium in place of hydrogen, just because of some differences which we are going to be explaining in our other videos. Are we together now? Good. If that should be the case, then we can talk about its thermometric property now. The thermometric property of a constant volume gas thermometer is that the change in pressure of gas with a change in temperature at a constant volume. Are we together now? Constant volume gas thermometer, the thermometric substance there is gas. That gas can either be hydrogen or helium. But we majorly use helium because of some differences that we are going to be explaining in our later uploadings. Then the thermometric property is the change in pressure of gas with a change in temperature at a constant volume. Then the third one, which we are going to be talking about, is the resistance thermometer. The resistance thermometer makes use of pure metal as its thermometric substance. Are we together now? What is now the thermometric property? The change in resistance of the pure metal with a change in temperature. You know that when resistance increase, it shows that temperature has what? Increased. When temperature reduce, resistance has also what? Reduced. The change in, when it comes to pure metal, the change in what? The resistance of a pure metal with a change in temperature is what we refer to as the thermometric property of a resistance thermometer. Do we understand this now? It must be pure metal because pure metal responds positively to resistance. It's not having a negative coefficient with resistance. We'll be talking about that when we get to our electronics class. Is that taken? When we talk about insulator and semiconductor and the likes, let's leave it till then. Then the next type of thermometer we have is the thermoelectric, which we call the thermoelectric. At times we call it thermocouple thermometer, whichever one, but it is called thermoelectric thermometer. It uses what? Two metal of different temperature that are joined together. That is, it uses thermocouple as what? Thermometric substance. And what is now the thermometric property? The thermometric property is the change in electromotive force of the two metals with a change in temperature. And lastly, which I will mention, we also have some other thermometer like that of clinical thermometer that also uses like the alcohol and the liquid in glass thermometer. That clinical thermometer is similar to liquid in glass thermometer, but we are not going to talk about that. We only want to mention 5 different types of thermometer, and the last one is going to be thermostats. Are we together now? So when we talk about thermostats, no, I want to talk about bimetallic thermometer. So when you talk about the bimetallic thermometer, the thermometric substance there is what? Two metals of different thermal expansion. Are we together now? Two metals of different what? Thermal expansion. Are we together? Therefore, the thermometric property there will be the difference in their expansion with a change in temperature. Those are the 5 that we are going to mention for this class. Do we understand that now? Good. The next one we are going to look at now is now the temperature scale. Okay? I already run out of space, so let's quickly look into that. Now, when you talk about the temperature scales, temperature scale. Now, the temperature scale is what actually lets you understand the units in which you express your temperature value. The temperature scale is what give you the units in which you are going to express your temperature value. And normally, fundamentally, the unit for temperature is Kelvin. That is, the fundamental scale for temperature is a Kelvin scale. So we have 1, the Kelvin scale. And we have 2, the Celsius scale. And 3, we have the Fahrenheit scale. These are the 3 scales of temperature that are commonly used. Are we together now? We have the Kelvin scale, the Celsius scale, and the Fahrenheit scale. Now let's discuss them one after the other. What is their difference? Their difference is that we need to understand at first that for every thermometer, they have what? They have the lower fixed points and the upper fixed points. Are we together now? So lower fixed point and the upper fixed point. What is lower fixed point? Lower fixed point is the temperature at which water will become ice at 70-60 millimeter mercury. The temperature at which water is going to turn to ice at 760 millimeter mercury is what we call lower fixed point. And the upper fixed point is the temperature at which water will turn to steam at 760 millimeter mercury. Do we understand the difference now? We know what we call lower fixed point and upper fixed point now. Good. The difference between the upper fixed point and the lower fixed point is what we call temperature interval, or you call it fundamental interval. Are we together now? So the fundamental interval is the difference between the upper fixed point and the lower fixed point. Are we together now? And any temperature scale whose fundamental interval is the same, we can consider them to be equal. And that is the case whereby Celsius scale is the same thing as Kelvin scale. Are we together now? We are going to continue. What is their Kelvin scale? For a Kelvin scale, the lower fixed point is 273.16 Kelvin. And the upper fixed point is 373.16 Kelvin. Are we together now? Why for Celsius scale, the lower fixed point is 0 degrees Celsius and the upper fixed point is 100 degrees Celsius. Then for the Fahrenheit scale, the lower fixed point is 32 degrees Fahrenheit, and the upper fixed point is 212 degrees Fahrenheit. Are we seeing the difference now? Now, if I take the difference, that is the fundamental interval of the Kelvin scale, 373.16 Kelvin minus 273.16 Kelvin, that will give us 100 Kelvin. And if I take the difference between the upper fixed point and lower fixed point of the Celsius scale, 100 degrees Celsius minus 0 degrees Celsius, that will still give me 100 degrees Celsius. You can now see that the magnitude of the Kelvin scale and that of the Celsius scale, their fundamental interval is the same thing. That is why if you are not dealing with absolute scale temperature, that is, if you are not dealing with gas, we don't need to convert Celsius scale to Kelvin scale. Why? They have the same fundamental interval. Are we together now? But if you check that of Fahrenheit scale, 212 minus 32, that will give us 180. It's not equal with that of Kelvin or that of Celsius. And that is why whenever you are given a temperature in degree Fahrenheit, there is always need for you to convert it to either Celsius or Kelvin, as the case might be. Do we understand that now? So that is that about temperature scale. So the last aspect of the class is going to be how to convert from one scale to another. So let's look into that now. How to convert from one scale to another. This simply means that we can convert from one scale to another scale. It's possible, yes. How do we go about the conversion? Let's say I want to convert from Celsius. Let's say I want to convert from Celsius to degree Fahrenheit. I want to convert from degree Celsius to degree Fahrenheit. Conversion from degree Celsius to Fahrenheit now. How do we convert from degree Celsius to Fahrenheit? Whenever you want to convert from one scale to another, all you just need to understand about the scale is for you to know the lower fixed point and the upper fixed point of the two scales, the one you are converting from and the one you are converting to. So, I'm converting from Celsius to degree Fahrenheit. So, this is the 0 degree Celsius, which is the lower fixed point of Celsius scale. And here is 100 degrees Celsius, which is the upper fixed point of Celsius scale. Now, the temperature I want to convert in degrees Celsius, this is it here. Let it be between 0 and 100 degrees Celsius. Okay? If that should be the case, this will now become this. For Fahrenheit that I'm converting to, the lower fixed point is this. And the upper fixed point is this. Let the temperature be F. Are we together now? That is 0 the degree Celsius is equivalent to degree Fahrenheit. So how do I take it? I'll take the proportion. That is 0 degrees Celsius. I say 0. Sorry. The degree Celsius minus 0 divided by 100 minus 0. Are we together? And this will just equal the degree Fahrenheit minus 32 divided by 212 minus 32. Are we seeing this now? Good. If that should be the case, this will give us the degree Celsius divided by 100 equal degree Fahrenheit minus 32 divided by 180. The 0 here will cancel this 0. Remember, this is degree Celsius. Now, if I cross multiply, I will have that 10 degree Fahrenheit minus 320 equal 18 degrees Celsius. Yeah, equal 18 degrees Celsius. Are you seeing this now? Thus, if that should be the case, I can take this one to the other side. Then if I do that, I will have 10 degree Fahrenheit to equal the 18 degrees Celsius plus 320. Are you seeing this now? Okay, if that should be the case now, I can divide both sides by 10. So if I divide both sides by 10, I will have that the degree Fahrenheit is equivalent to 18 degrees Celsius divided by 10 plus 320 divided by 10. So that this and this will cancel. I will therefore have that the degree Celsius is equivalent to degree Fahrenheit. Abi? So, okay, now let me make it like that. The degree Fahrenheit results is going to be 2 can divide 18 9 times. So we are going to have 9 degrees Celsius divided by 10 plus, sorry, divided by 5 plus 32. Are we there? So if let's say the temperature in degrees Celsius is equivalent to X. Are we together now? So we have that It's equivalent to degree Fahrenheit. So that is 9x divided by 5 plus 32. So this will be the value if you are converting from Celsius to Fahrenheit. Now, how do you convert from Fahrenheit to Celsius? To convert from Fahrenheit to Celsius, it's also simple. All you just need to do is to take the same procedure, but you are going to make x the subject of the formula. Is that okay? So we can just do that here. X equal 5 in degree Fahrenheit. Okay. Okay, let me take it like that. 5 times this. 5 in degree Fahrenheit equal 9x. I say this now. Plus 5 times 32. Okay. Okay. Let me make it more simpler. Instead of doing that, transfer this to the other side. So we have this minus 32 equal 9x over 5. So if you cross multiply, we have 5 into degree Fahrenheit minus 32 equal. So that will be 9. That will be 5 into the temperature in degree Fahrenheit minus 32 divided by 9. So this is how to convert from degree Fahrenheit to degree Celsius. So this x is in Celsius. Do we get this now? Good. Now let's see how to convert from degree Celsius to Kelvin. So you can master the formula or you just master the procedure. So from Kelvin, from degree Celsius to Kelvin, or vice versa. So we said this is 0 degrees Celsius, 100 degrees Celsius. So the temperature in degrees Celsius, we want to convert it to 273 and 373, the temperature in Kelvin. Are we there? So if that should be the case, this should be C minus 0 divided by 100 minus 0. And this would be K minus 273 divided by 373 minus 273. So if this is what we have, this will just give us C all over 100 equal K minus 273 over 100. This and this will cancel, so C equal K minus 273. So if you are converting from Kelvin to Celsius, you just subtract 273 from the value given. And if you are converting Celsius to Kelvin, you just add 273. So that's how we come about that. Is that taken out? Thank you. That's that about how to convert from one scale to another. So the next thing we need to understand in this class is to solve our top 5 question. Now, let's see how we go about that. So we are to solve our top 5 question. The first question here states that what is the value of 20 degrees Celsius in Fahrenheit? Okay, a minute. Okay, back. What is the value of 20 degrees Fahrenheit? So, in degrees Celsius, we are looking for the value of 20 degrees Celsius, rather. Okay, what is the value of 20 degrees Celsius in Fahrenheit? So we have 20 degrees Celsius. I want to convert it to Fahrenheit. So how do we go about that? We just draw the scale that we are converting from, which is degrees Celsius. Are we together? And this is what? 20 degrees Celsius. We want to convert it to Fahrenheit scale, whose lower fixed point is 32 degrees Fahrenheit and the upper fixed point is 212 degrees Fahrenheit. So let the temperature equal F. So we do the same proportion, or you just apply the formula we've created. So that will be 20 minus 0 divided by 100 minus 0. And this equal F minus 32 divided by 212 minus 32. So this will give us 20 divided by 100 to equal F minus 32 divided by 180. This and this will cancel. 0 will cancel this. So we'll have 2 times 18 equal F minus 32. So this will give us 36. So 36 plus 32 That will give us the value for F. So F equal 68 degree Fahrenheit. Therefore, the value for 20 degree in Celsius, 20 degree in Celsius is equivalent to 68 degree in Fahrenheit. Do we understand that now? So let's go for the second question now. So as for the second question, we have that the ice, we have to take attention to this very well. The ice and steam points of an ungraduated thermometer are 200 millimeters apart. Calculate the length above the ice point, which will correspond to a temperature of 30 degrees Celsius. What are they telling us? We are told that the distance between the ice point, that is the lower fixed point, and the steam point, which we refer to as the upper fixed point, is 200 millimeters. That is, if this place is 0 millimeter, here is going to be 200 millimeters. So we are asked to calculate the corresponding length that will be the corresponding length of 30 degrees Celsius. Now, how are we going to go about that? If the distance between 0 degrees Celsius and 100 degrees Celsius is 200 millimeters, then what will be the length, the distance between 0 degrees Celsius and 30 degrees Celsius? That is what the question is all about. Let the distance be x. So if the distance is x, we take the same proportion, x minus 0, then 200 minus 0 equal 30 minus 0 divided by 100 minus 0. So this will be x divided by 200 to equal 30 divided by 100. This and this take care of each other, and this will take care of this. There I will have that x equal 3 multiplied by 20. So x equal 60 millimeter. Therefore, 30 degrees Celsius is equivalent to 60 millimeter. And that will be our correct answer. Is that taken out? So let's go to the third question now. Okay. So the third question states that calculate the length which corresponds to a temperature of 20 degrees Celsius if the ice and steam point of an ungraduated thermometer are 400 millimeters apart. This is similar to the question we just solved now. So this is just going to be 0 millimeter, and this will be 400 millimeter. So we are told that if this should be the case, we should calculate what the length of 20 degrees Celsius would be. So how are we going to get that? We can just say that this is x millimeter, as we did the other time. So we have that x minus 0 divided by 400 minus 0 equal 20 minus 0 divided by 100 minus 0. So this will be x over 400 to equal 20 divided by what? 100. So this will take care of this take care of this. So if I cross multiply, I have that x equal 80 millimeter. Do we understand this now? Good. Let's go for the fourth question now. So as for the fourth question, we have that the length of a mercury thread when it is at 0 degrees Celsius, 100 degrees Celsius, and at unknown temperature theta is 25 millimeter, 225 millimeter, 175 millimeter respectively. Find the value of theta. This is very similar to the problem we solved earlier. I decided to bring them because they always appear to be difficult, but absolutely they are simple. Are we together now? Okay, let's just see that. If this is 0 degrees Celsius and this is 100 degrees Celsius, and here is theta that we don't know the value, then we are told that the 0 degrees Celsius is correspond to 25 millimeter, and the 100 degrees Celsius is correspond to 225 millimeter. Then we are we have that theta is corresponds to 175 millimeter. What is the value of theta? We take the same procedure. That is, you can see that everything about temperature is quite simple. They take the same procedure. All you just need to understand is to know the one that is at the lower fixed point and the upper fixed point, then you are good to go. Thank you, guys. Okay, so this will become theta minus 0 divided by 100 minus 0. And this will equal 175 minus 25 divided by 225 minus 25. Therefore, theta all over 100 is going to be, this will give us 150 divided by 200, right? Good. This and this will take care of each other, and this will take care of this. 2 here, 1, and 2 here is 5. So if I cross multiply, I will therefore have that theta equals 15 multiplied by 5. So theta equals 75 degrees Celsius. Do we understand this now? So because 5 times 15 will give us 75. Do we understand that? Good. That's the fourth question. So let's look at the last question now. The last question is what we are to look at now. And what was the last question state? The pressure, okay, this one has to do with gas, okay. The question says the pressure on the gas of a constant volume gas thermometer at the ice point is 325 millimeter mercury. At the steam point, 875 millimeter of mercury. Find the temperature when the pressure of the gas is 490 millimeter mercury. We get with the same thing. Good. So we just say the pressure at the ice point, which is the lower fixed point, is 325 millimeter mercury. And the pressure at the steam point is 375 millimeter of mercury. Then we are looking for what will be the corresponding temperature at 490 millimeter of mercury. Okay, so we draw the corresponding value in degree in Kelvin. This is 273 and 373. Then we are looking for the value of theta. Okay, you take the same proportion like we do before. 490 minus 325 divided by 875 minus 325 equal theta minus 273 divided by 373 minus 273. Okay, so if this should be the case, we are then going to have that if I cross multiply here now, let's check our calculator for whatever the value would be. Okay, I think this will give us 165 multiplied by 100 divided by 550 rather, plus 273. That will give us the value for theta. So if that should be the case, this can take care of this. Then theta is equivalent to 303 Kelvin. So you may be asked that what will be the value in degrees Celsius? So in degrees Celsius, you just do what? You subtract 273 from this, then you know what the value will be. At this junction, we are done with everything called temperature and its measurement. So do well by subscribing to this channel. If you're yes to do, drop a positive comment and tell us how you want us to improve on this channel. Do have a lovely day. Thank you.